So we have a challenge when you do your day-to-day activities. So you have to buy, you have to take different things in different manner, different method having quantitative value. That means if you need to buy sample of sugar, you need to go to the boutique and you have to take as certain quantitative value as an example 500 grams of sugar, 1 kilogram of sugar, like this. Then if you deal with your day-to-day activities, definitely you must use quantitative value. But here we are not going to learn about the things we buy as quantitative manner in day-to-day life. That topic is depending on measuring something here means elements and compounds quantitatively. So at the very beginning, I would like to show materials you familiarize with your day-to-day life. That is gram seeds. They are green grams, and that is sample of dal. So there is no doubt to measure the mass of gram seeds, green grams, and dal separately using balances. But the problem is arising with us. Why? The fundamental unit of each component, whether it is gram seed, green grams, or dal, its building unit is atom. These can be measured by using different balances because of why they can be touched by our hands. They are visible to our naked eye. But the thing is, the building unit of each compounds mean here these examples, cannot be measured, cannot be touched, cannot be seen through our naked eye. Therefore, we must have another strategy, a device to measure the mass of an atom. That is indivisible for the indivisible unit of each matter, cannot be measured by using different balances. Therefore, we must have another tool to measure the mass of an atom. So, very first, we will need to learn what do you mean by an element. So, you have learned since grade 8, 9, so as well as in 10, an element is a pure substance which is built by same kind of atoms. As an example, hydrogen is an element, oxygen is an element, nitrogen is an element when you take it as individually. So that is the definition of an element. An element is a pure substance, I told last, pure substance which is built by the combination of one kind of atoms. If you take hydrogen element is composed by same kind of hydrogen atoms, right? Then we must have the idea what do you mean by compound. Compound also a pure substance. The difference between an element and a compound is built by two or more elements combining chemically together. So that is the definition relevant to the compound. So we are learning about elements and compounds separately because of why in this unit you are learning about measuring the mass of an element compound separately. Therefore, you must have simple idea about what is an element, what is a compound. So compound is a pure substance which is built by combining two or more than two elements. As an example, when one hydrogen atom is combined with another hydrogen atom, H2 will be formed. H2 is not 10 atom. There are two hydrogen atoms, so therefore H2 must be a compound, otherwise in simple term molecule. Molecule is made up by combination of two or more than two atoms. Either it is civil or polycivil. Then you know thoroughly about what is an atom, what is a compound. Then we need we must have a strategy to measure the mass of an element and compound separately. Therefore, we must have a certain tool. So I have taken the nice balance. There is no such a balance in science field. It has planned to take an idea to how to measure mass of an atom. Therefore, if you think about it, it is happening as a measuring substances in our day-to-day life by using balances. That is also done like that. There is a certain balance. Here, if you need to measure 1 kilogram of dal, you have to put 1 kilogram of weight to one pan, and the other side should be fulfilled with dal. Then when the two sides are getting equal, you say there is 1 kilogram of dal. Likewise, mass of an atom also should be measured when there is a standard unit. Later on we will discuss what is that standard unit, that is called atomic mass unit. So roughly you can take an idea. The mass of an atom is not expressed here. Atomic mass unit means there are certain standards have been used by different scientists since past, but today, though there are several scales, C12 atom is used to measure the mass of an atom by dividing it 12. That is called atomic mass unit. Let's learn further more. Then if you need to measure the mass of an atom, you have to keep that standard scale on one side of the balance. Then the next side should be filled with the particular element or atoms of particular compound. When two sides are getting equal, it is measured as its mass. Right. So the standard tool we use to measure the mass of an atom or mass of a molecule, otherwise compound, the standard tool is atomic mass unit. Atomic mass unit, in simple form we call AMU, atomic mass unit. Atomic mass unit means the mass of 6C12, 6 carbon 12. Here the 6 mean atomic number, 12 mean mass number. 6C12, some books mention as C12 atom. When the mass of C12 atom is dividing by 12, you will take a certain value. Its value is 1.66 into 10 to the power minus 24 grams. So there is a certain value for the mass of C12 atom, otherwise mass of 6C12 atom. It is 1.99 into 10 to the power minus 23 gram. When it is dividing by 12, you will take 1.66 into 10 to the power minus 24 grams. That is called as 1 AMU, atomic mass unit 1. Then relative means, the simple word, relative means you have to compare. When you measure in 1 kilogram of sugar, you are putting 1 kilogram weight one side, then the other side is comprises with sugar. Then you are compare the weight of the sugar with parallel to the weight of 1 kilogram weight. Here also we do such a process. If we take the mass of an atom into one side, as I have shown in the earlier one, then the other side should be fulfilled with the mass of a particular atom. If you need to measure the mass of hydrogen atom, you put hydrogen atoms into one side. Then atomic mass unit mean the mass of 612 atom is divided by 12 of that scale is put into the next side. When the two sides are getting equal, we call relative atomic mass of hydrogen. That means the mass of hydrogen is measured with parallel to the atomic mass unit. Right? That is the common equation we use to measure the relative atomic mass. It is symbolized by capital A must be written in large manner. Then the R should be written in simple, but it should be somewhat smaller than capital A. Mass of an atom of an element. When you find the relative atomic mass, the word must be emphasized. Atomic mass, we are going to find the atomic mass, then the numerator must be mass of an atom. But the denominator is same standard unit we call atomic mass unit. Here, but you have learned atomic mass unit means mass of C12 atom is dividing by 12. That dividing signal is going as a multiple mark as 12. So there is no error if you write the equation. That is the common equation we use to find the relative atomic mass. Right? Then mass of an atom divided by mass of 12 atom into 12 is the relative atomic mass. Now we are going to find how to calculate relative atomic mass of an atom. Relative atomic mass of an atom. Then let's see the data we have supplied. The mass of a potassium atom is here 10 to the power minus 23 gram. That means it is not a very high value, it is very tiny value. It is very tiny value. Minus 23 means there are number of zeros behind the decimal point. Right? The mass of potassium atom is 6.476 into 10 to the power minus 23 gram. The mass of C12 atom is 1.99. I told earlier on, the mass of C12 atom is 1.99 into 10 to the power minus 23 grams. Then you are asking, find the relative atomic mass of potassium. When you are giving such a question, you must be able to memorize the particular equation. Particular equation is relative atomic mass is equal. That is the way. Relative atomic mass of potassium is equal. Then the denominator must be, there is potassium atom is given, therefore, the numerator must be mass of potassium atom divided by mass of C12 atom into 12. Here, mass of potassium atom is given as 6.476 into 10 to the power minus 23 gram. Mass of C12 is given here 1.99 into 10 to the power minus 23 gram. Right? Then let's see next. They are the values. Here, grams to grams can be cancelled. 10 to the power minus 23 to 10 to the power minus 23 cancel. When you take the whole value 6.476 divided by 1.99 into 12, you will take such a value. The value is 39. Here, answer must be 39. So, relative atomic mass of potassium is 39, means it is 39 times rather than atomic mass unit. Atomic mass unit එක වගේ 39 ගුණයක් තියෙනවා potassium. Let's see next one. Relative molecular mass. So already we have discussed about atomic mass with parallel to the atomic mass unit. Then we go relative atomic mass. Here we are going to learn about relative molecular mass. Then the word must be emphasized here as molecule. If you write the relative molecular mass, here we have taken as capital M simple R. The atomic mass, relative atomic mass has expressed as AR, relative atomic. Here relative molecular mass. Mass of molecule divided by, but the denominator must not be changed. Either it is atomic mass, either it is molecular mass. Here the mass of C12 atom into 12 should be used as same manner to calculate relative atomic mass as well as relative molecular mass. Right, let's find the way of calculating relative molecular mass of compound. Let's see. If the true mass of carbon dioxide molecule is 7.31 into 10 to the power minus 23 grams, mean very tiny molecule. Mass of a carbon atom is given as earlier on 1.9 into 10 to the power minus 23 gram. You are asking to find the relative molecular mass of CO2. Let's see. Then the relevant equation should be relative molecular mass of, we are going to find the carbon dioxide, right? Relative molecular mass of CO2. Then in the equation the denominator must be mass of C12 atom. Let's see how it happens. Mass of C12 atom but the numerator must be, now it is a molecule, we are going to find the mass of a molecule, therefore numerator must be mass of molecule of carbon dioxide. Right, let's see the values of each. Mass of molecule of carbon dioxide is given here. 7.31 into 10 to the power minus 23 gram. Then the numerator must be that value. Denominator should be mass of C12 atom. There is 1.99 into 10 to the power minus 23 gram, but it must be multiplied with 12. Likewise. Here also gram to gram cancel. 10 to the power minus 23 to 10 to the power minus 20 in denominator will be cancelled out. Then whole number will be taken as 44. So relative molecular mass of carbon dioxide should be 44. We have taken that value in earlier also. Then there is a shortcut to calculate the relative molecular. That is the longest method. That is very difficult to find the relative molecular mass, because of why you should be able to remember the equation to here. A shortcut. Now let's find the same thing, but we do the thing very convenient manner. Let's see how to find the relative molecular mass. That is done to calculate relative molecular mass of a molecule. It cannot be used to apply to find the relative atomic mass. Right, that is question number 1. Find the relative molecular mass. I have taken it as symbol form. Relative molecular mass of H2O. H2O means water. Water is built up by 2 hydrogen atoms and 1 oxygen atom. When you look at whatever molecule, you should be able to decide how many atoms in it. What are the atoms in it? Likewise, there are 2 hydrogen atoms and 1 oxygen atom. If you are asking to calculate relative molecular mass of a molecule, relative atomic masses must be offered in the particular data. Likewise, there are 2 hydrogen atoms in the molecule, right? Hydrogen atoms, there are 2. Then value of 1 hydrogen is 1. 1 into 2 means 2, right? Then next one. There is only 1 oxygen atom. Here, 1 oxygen atom. Value of 1 oxygen is 16. 16 times 1. Why there is only 1 oxygen atom? Gas is 18. So 18 is the relative molecular mass of water. Now let's see next one. Find the relative molecular mass. MR means relative molecular mass of CO2. You are given relative atomic mass of the molecule built here. There is 1 carbon atom in CO2, 1 carbon 1. But the value of 1 carbon is 12. 12 into 1 means 12. Because of why there is 1 carbon atom. Here, CO2, here there are 2 oxygen atoms. Oxygen, there are 2. One value of 1 oxygen atom is 16. 16 into 2 means 32. When you take the summation of each atoms in the compound, you will take it as 44. 44. So you have taken the relative molecular mass of CO2 as 44 in longest method as well as shortest method. That is the very convenient method. Right. Question number 3. I have taken question number 3 because of there is a little difference between that of magnesium hydroxide. Here, when you take the count of different atoms in the compound, some students may take a misunderstand how to take the number of the atoms present in the bracket. Here, 2 present out of the bracket says it is common for the each atom present in the bracket. And as an example, there is 2. When there is oxygen, 2 must be multiplied by oxygen. Then there are 2 oxygen. There are 2 hydrogen likewise. Let's see. There is only 1 magnesium. Magnesium 1. Value of magnesium is given always. 24 into 1 means 24. Next one. There are 2 oxygen, I told. If there is whatever number out of the bracket, it must be multiplied in the atoms in the bracket. 2 oxygen. Value of 1 oxygen is 16. 16 into 2 means 32. Hydrogen. There are 2 hydrogens. There are 2. Value of 1 hydrogen is 2. 1. 1 into 2 means 2. Then altogether you will take the summation of magnesium hydroxide as 58. 58. They are the shortest method that we have to follow to calculate the relative molecular mass of a molecule. Then you have a chance. At home, you should be able to calculate these substances and find the relative molecular mass of each. Then it's better to calculate one by one how it comes, what are the number of atoms present in it. Likewise, if you can take at the very beginning, it is very convenient to calculate the molecular mass thoroughly, right? Let's see. You have to calculate the relative molecular mass. MR means not atomic mass, relative molecular mass of the given compounds. They are the compounds. You are given relative atomic mass of each. Then you will find relative molecular mass. If you don't know whether it is atom or molecule, there is Ca3PO4 brackets twice me. There are lots of atoms. If there are more than one atom, we call molecule. So everything given here is molecule. Calcium phosphate, copper sulfate, aluminum nitrate, calcium bicarbonate. In each compound are molecules, so you should be able to calculate its molecular mass, relative molecular mass. Right, then I think we will use, you have taken little idea about to find out relative molecular mass, relative atomic mass, and there is a certain standard unit to measure the mass of an atom. That is the main idea behind of this unit. Then I think that you have taken the relevant idea to calculate the relative atomic mass and relative molecular mass. Then we will meet later. Thank you very much.